Hello and welcome back to the third geostatistics course with QGIS and R. The main topic of this course is structural analysis for Kriging Cokriging interpolation. This is just a summary of the 5th lesson of the course, and today we are going to be talking about model semivariogram. We are going to start this lesson plotting the experimental semivariogram with the line of the variance. It is interesting to know what is the value of the variance in order to have an approximately idea where the sill of the semivariogram model is going to be located. The sill doesn't have to present the same value as the variance. It's just an approximation. It means that the value of the sill could be higher or smaller than the variance value. Later, we are going to introduce the theoretical semivariogram models, and we are going to be talking about the 3 most important ones. They are the spherical model, the exponential model, and the Gaussian model. Also, we are going to talk about their mathematical expressions and how they look like graphically. In addition, we are going to be talking about other parameters like the range, the nugget, the partial sill, the correlated area, and the uncorrelated area on the graphs. It is interesting to know that there are a lot of theoretical semivariogram models that can be adapted to different type of scenarios according to the data. However, in this course we are going to talk just about the nugget, the spherical, the exponential, and the Gaussian model. The rest of the models are going to be out of the scope of this course. Later we are going to start to work with the script to plot the theoretical semivariogram model on the data. As you are going to see, with this script, the theoretical semivariogram model is going to fit on the data automatically. The only thing that we have to provide to the script is the approximated values of the partial sill, the nugget, and the range. And we are going to see how easy and fast is to change from one model to a different one with this script. Then we are going to see what is the relation between the theoretical exponential model and the range that we get automatically. Later we are going to work on a script that is going to provide us what is the best theoretical semivariogram model that fits in our data. And this process is going to be automatically. Then the only thing we have to do is to provide the data, and the software is going to tell us what is the best model. It makes our lives easy. Now the next question is, what happens if the values that the script provides me automatically doesn't convince me? Then we are going to work on a script that we can fit the theoretical semivariogram model manually. It means that we can select the values for the range, for the partial sill, and for the nugget effect. And then we are going to have a theoretical semivariogram model that fits in our data according to those values. As a summary, we can say that in this lesson we created 3 different types of scripts. The first one, it was related to the fit of the theoretical semivariogram model on the data automatically. But for this script we have to provide what model we want, the spherical, the exponential, or the Gaussian, and also the approximated value of the partial sill, the nugget, and the range. The second script tells us what is the best theoretical semivariogram model that fits on the data. And we don't have to provide any parameter like the partial sill, the range, or the nugget. The script provides us the best model automatically. And the last one is related to the fit of the theoretical semivariogram model on the data, but this time it's manually. It means that we can decide what values we want for the partial sill, for the range, and for the nugget. And all these scripts has been created for data that is stationary and also for data that presents a first order trend surface. At the end, we are going to see how the changes on the range and also in the nugget can affect the structure of our data. As we saw with the last script, we can make some modifications on the range, on the partial sill, on the nugget effect, but these changes have strong implications in our theoretical semivariogram model. Then, as we are making changes on the model, that is going to be reflected on the estimation of the parameter of interest. And we have to know what are these implications. This course is not available in YouTube. If you want to have full access to the course, just go to GeoRGV community website at gscourse.online, then go to courses, select the third geostatistic course, structural analysis for Kriging, Cokriging interpolation, then get enrolled, start the course, and here you are going to have all the lessons that we added already. The summary for today is for the lesson number 5, Model Semivariogram. That the total content of this lesson is almost 1 hour, as you can see over here, 48 minutes. Also here at the bottom you have the scripts that we was using in this lesson that can be downloaded. And also it is loaded the last lesson. The last lesson is related with the variogram map, where we are making the study of the isotropy and anisotropy of the data. Well, that's it for this video. Thank you very much for watching and see you on the next lesson.